Welcome back to another multimeter review. It's a cheapo multimeter review. Today in the spotlight, it's Aneng time one more time. It's the Aneng AN819A, and this little beastly bad boy has a few tricks up its sleeve. And you know what? Hey, I'm always one for a few tricks up the sleeve. Let's take a closer look. First thing you notice about the AN819A, try saying that 3 times backwards, is the fact that it is a pretty good looking meter. I like the color choices they've utilized. All in all, it's easy on the eyes and it does stand out. It's a fairly decent sized multimeter. It's not a miniature. If we put it up against the UT89X, for example, it's basically the same size. In fact, it even is about the same width. So that gives you a good indicator of what you're looking at. Ergonomically, it has that nice multimeter look and feel. I'm not crazy about the rubber boot or holster that they've utilized in this case. It feels more cheap plastic than something quality. So I think they could have definitely taken that up a notch. Now, once again, this is a cheapo multimeter. This is about 15 bucks Canadian. That's what I paid for it. So around $12 US. So really, it is bargain basement in terms of price. Let's take a closer look at that range switch, starting off the 12 o'clock off position. Next, it's HFE or transistor mode, followed by volts DC up to 1000 volts, volts AC up to 750 volts, amps AC up to 20 amps, amps DC up to 20 amps, capacitance up to only 200 microfarad, diode mode and continuity, resistance up to a very useful 200 mega ohm, live wire mode, and finally back to the 12 o'clock off position. Taking a look where the input jacks go, we can see that there is a separate input for the milliamp. There's our 20 amp unfused. Milliamp is sitting at 200 milliamps fused. And here we have the voltage resistance, continuity diode, and live wire, and the basic COM. Not a whole lot of bells and whistles for the Aneng. We have your basic touch hold, nothing fancy going on here. Here we have your standard HFE or transistor tester, and a nice inclusion is a visual continuity indicator. Aneng has done a really good job as of late in terms of the actual display of the multimeters. Whether they're cheap or not so cheap, the AN819A does have a nice display. Now, there is no backlight on this unit, strictly a non-backlit unit, so having a good crisp vibrant LCD or liquid crystal digital display is of importance. And once again, they did a good job. It's clear, it's vibrant, digits aren't too big, they're not too small. In fact, I think they're pretty well perfect. Unfortunately, when it comes to the tilting stand or tilting bail, it's not such good news. It just flops around, it does not stay, and it's just drives me crazy. So too bad they couldn't somehow have made this a little better. Probes themselves are super cheap. Honestly, for me, they just feel like complete garbage compared to the other Aneng M1, which I tested not very long ago. Those weren't half bad for cheap leads, but these even feel worse than those. It's a different type of plasticky feeling, but I mean, it just feels like complete crap. So I will use these for the testing, but if you do hang on to this multimeter, decide to purchase it, definitely upgrade the leads. On the reverse ends of the leads as well, you can tell next to no shrouding. They have that crappy little banana jack insert style. A real fail. Starting things off, we're going to look at the basic DC accuracy with the voltage reference, and we should be looking at 250 millivolts, currently sitting at around 249. Now we should be looking at 2.50 volts, and we are 2 counts out at 2.48. Checking out the AC voltage now, sitting at 121 volts, which is spot on. This meter does not show us frequency or duty cycle. Next up is milliamp mode, low current. Here we come. We're sitting right now around 75 milliamps. Now this only has a 200 milliamp threshold, not very high, but let's see go a little bit higher, sitting at 130, 140, 150 milliamps. And we are not showing any difference. How come? I see, said the blind man. Okay, 150 milliamps. There we go. Take it up a notch to 160, 170, 190 milliamps. So far, so good. Let's try and hit the threshold of 200 milliamps. Over limit. Okay, can we bring it back down ever so slightly? 195. I'm going to bring it up to 300 milliamps. And I'm going to bring it back down. 130 milliamps, and there you go. So we're going to take a look inside. I brought it right up to actually 450 milliamps, and it's still alive. See what they're using in terms of a fuse when we do the open up segment a little bit later. So 200 milliamps is the maximum for low current testing with the Aneng AN819A. Next up is resistance mode. Yes. Now this meter has a whopping 200 mega ohm resistance range. Better than most, and certainly capable for most people's needs. Now, I'm going to first try rolling out the test leads that it ships with, see if we have any internal resistance in these leads. 0.3, 0.2. So we have a little bit. Now, there's no way for me to delta out that resistance. There is no rel feature with this meter, so we just factor that into the equation. And look at that. Now we have a low battery light. Oh, wow. Things are going crazy in the world of Aneng. What's going on? And the meter just died. Wow. Okay, guys, let's, that's interesting. So let's just keep rolling. And let me just open this up. I thought I had put in a brand new battery in this meter. So, let's see what's going on here. Okay, I didn't want to do a look on the inside just yet, but let's take a look. Now that has not happened before, so really curious. Let's see here. Now this does take one standard 9-volt battery. Okay, we'll just take that apart. Let's keep that battery right here, and let's see what that battery's got in terms of juice. Okay. Here we go. Is that battery any good? Ah! Did look good though before I went splattered. 9.57, so that battery is, yeah, fine. It is a brand new battery. So why did everything fade to darkness? Aneng, what the hell is going on? Okay, I will put in another battery and we'll try this again. Well guys, this is going to be a very short review because this Aneng has died. Yes, it has literally died on the lab test bench after only 10 minutes. I've tried multiple batteries. This is the 5th. This one is not a Duracell. I did try Duracells as well, but yeah, it's just nothing. Nothing coming out of this meter. Let's verify this battery again. Wow, now this was completely full before I put it in. Now it's actually down about 0.5 volt. So there is something sucking the juice right out of these batteries. Awesome. Double check this one again. 9.6. I'll try this one more time. Wow. Very disappointing, actually. I mean, that last Aneng was a really good little meter. Okay, well, we're back in action. Let's see how long this stays alive. Okay, so we were in resistance. Stuck with it. We have no delta rail out feature with this meter. Okay. Here's a 22 mega ohm resistor. Might help if I bring it up now. And 23.3. Okay, here we've got a 0.5 ohm resistor. 0.9, fairly close. Just not feeling it with this meter though, not after this last little interesting incident. Let's try this diode. And we do have the forward voltage drop. And we will go to capacitance mode. Got a 0.01 microfarad capacitor. 0.02. Pretty darn close. That works. Here's a 3.3 microfarad cap. Wow, interesting. Try bringing it up a notch here. Polarity is not an issue with this type of electrolytic cap. And 3.3 microfarads, it is not seeing anything. Wow. So complete fail in terms of capacitance. Yeah. All right, well, we've got something here called live voltage detection. Let's try that out. We're in live voltage mode now, that little flashing lightning bolt. And I will probe it into a live power source. And let's see if we have anything. And we have absolutely nothing. Good way to kill yourself here. Yeah, so, wonderful Aneng, telling us that there's no live power. Okay. Okay, we're going to continue this painful sojourn. We're going to try continuity now. Default test leads, here we go. Wow, it actually works. Something works on this meter. I'm excited. Let's try that again. It's actually really fast. It's not latched, scratchy, but I like it. And we have that visual indicator as well, so Next up, we've got the Probe Masters. And they have their little protectors on because I keep stabbing myself with them. All right, here we go. Wow. Really fast. A little bit louder. And, you know, once again, that visual indicator is really nice. So, hey, the continuity is nice. Something works on this meter. Next up is LED testing, and let's see if this thing will stay alive long enough to illuminate these LEDs. Hey, speaking of illuminating, electroluminescence is actually a pretty neat natural phenomena. And LED technology is built around this sort of discovery. And guess who discovered it? Well, credit goes to Guglielmo Marconi. That's right, back in 1907. Now, in terms of the actual light-emitting diode itself, this goes to Nick Holoniak, and he was an engineer for General Electric. And he's been credited with the first visible light-emitting diode. So you have just a little bit of background about these wonderful little semiconductors. Okay, here we go. Starting off with the yellow, and we have a forward voltage drop indicator. Green, it's not lighting, but it is giving us a forward voltage drop. Next is the red, and it's lighting it up. 1115. That just seems a little off. So it is lighting up, or illuminating, all of them except the green. But it is acting slightly bizarre. 1113. Getting a second opinion on these LEDs because something just didn't seem right, and according to the Kairitsu, that forward voltage drop is about 1.8 volts. And I verified that as well with the UT195E. But if we look at the same with the Aneng, instead of 1.8, we're showing 1.155, so really low. So, yeah. In terms of LEDs. Well, they say it isn't over until the fat lady sings, and I hate her. No fat lady singing just yet. So let's take a look at the inside of this bad boy in more ways than one and see what we've got. We'll start off with the input jacks themselves. Now, these are the really cheap variety. Now, they're not cheap because they're split. There's nothing wrong with split jacks, as I've said before. But in this case, they're really cheap tin material. I mean, this feels like it's going to come off any second. Horribly cheap, and yeah, complete garbage. And oh wow, look at that soldering. It's really bad soldering too. It's missed. It's actually missed the soldering joint. I don't know if you can even see that or not. Yeah, the blob is only covering half of the hole, so yeah. Okay, let's take a look at that input protection. On the milliamp side, they've incorporated once again a poly style resettable fuse, 250 milliamp. This one is coded as the GR265-200. So that will automatically reset itself when you go over about 200 milliamps, as you had seen previously. Now, the nice thing about that is that it is self-recovering. It only takes a few seconds and you're back in business. So there is no milliamp fuses that need replacing. So that's a good thing. I really like this idea being invoked, especially in the lower end multimeters. I think it's a great idea. Now, in terms of the actual high current fuse, there is none. Strictly a current shunt, capable, they're saying 20 amps for around 10 seconds. There is no fuse to be seen whatsoever. If you take a look over here at the voltage side of things, we have one lonely PTC, and that is all we have in terms of the input protection for the voltage department. So not a whole lot going on here. I do like that inclusion once again of the resettable polystyle fuse. So once again, that piezo is just stuck onto the PCB with a little bit of rubber and glue, and that is what is powering that sound. Taking up a notch here, the IC is cobbed. It's an LM358, that's the dual operational amplifier. And this here is a Schmidt trigger. That is the 74HC14. It's a hex inverter with Schmidt trigger inputs. And pretty well, that is it. We do have a diode here, probably for the reverse input protection. Not a whole lot else going on. You know, this meter has died about 4 or 5 times since that initial testing that was live. Yeah, so anyway, I thought it'd be a good idea to take a quick look on the inside and just see what they're offering. The PCB has a fabrication date of March 2018, so just about a year old. Thank you very much. And that's about all she wrote. I'm going to put this back together and come back with my closing thoughts. Final thoughts on the Aneng AN819A. It is crap. Wow, that was simple. It died relatively quickly. I had only been using it perhaps for a couple of hours, doing some pre-testing, what have you, but this thing is a piece of garbage. Unfortunately, even though it had a nice crisp display, now it has no display at all. Leads that it came with were utter crap. perhaps this is just a one-off, perhaps not. Very disappointing considering that the previous Aneng I had reviewed, the M1, was certainly a decent, high-quality little pocket rocket for a lot of bang for the buck. The Aneng 819A is not. And it's getting a measly 1 star. Thanks for watching this review, everybody. Don't forget we're having the Unity week of reviews starting April 14th to the 21st. 7 days, a new review every day, all Unity. Multimeters, power supplies, and everything in between. It's going to be a lot of fun. And stay tuned for the next live chat, which will actually be live. Hope you enjoyed this review. Till the next time, keep on testing.